Lesson 6.3 is finding the volumes of pyramids and cones. Up to this point we have found volumes of prisms and cylinders. Here we have a picture of the Rock and Roll Hall of Fame building in Cleveland, Ohio, and part of the building is actually a glass pyramid. The entire building was designed by architect I.M. Pei and has approximately 150,000 square feet of floor space. So it's a pretty big place. If you ever get a chance to go there, I think you'll think it's kind of cool. Here, this first shape is an example of a pyramid, and this particular pyramid, we name the pyramids just like we name a prism. We name it by their base. So the base here appears to be a rectangle, and all the faces of the pyramids are made of triangles. Remember, all the faces of a prism were made of rectangles, but a pyramid has all faces a triangle, and then the base can be a different polygon. So go ahead and fill this in. This is a rectangular pyramid. This is also a pyramid, and notice the height. They're showing you the height of the pyramid. The height of the pyramid goes straight through from the top of the pyramid straight through perpendicular. Remember, that's a right angle. So straight through perpendicular to the base. Here you can see that the base is shaped as a triangle. So this is a triangular pyramid, triangular pyramid. And finally, this shape here is a cone. You have a circular base. It still looks sort of triangular to the sides, but they're not actually a triangle. If I were to pull this apart, and I can show you a demonstration in class, it's kind of a cool looking shape when you pull it apart. So this is a cone. Okay, so here we're going to go over the formulas for this. The volume of the pyramid is 1/3 of the area of the base, so the base shape times the height. So here they're giving you an example. The base shape is a rectangle, or in this case actually it's a square, 3 by 3, so that's 9 square units. And the volume is 1/3 of the base area times the height, and the height of the pyramid is 4. So this turns into 12 units cubed. So fill this in. The volume is 1/3 BH, or a lot of times I write it as BH over 3, because when you take 1/3 of something, you're really just dividing it by 3. So write this formula in as well. Next we have the cone. We know that the base of a cone is always a circle, and we know the area of a circle is always pi r squared, and then it's 1/3 of the circle times the height. So it's a circle, it's 1/3 of the circular area times the height again of the cone. So here we have pi r squared, the radius is 2, so here is the area of the circle. We take 1/3 of that times 3. When we take 1/3 of 3, it's 1. 1 times 4 pi is 4 pi, and then we approximate it. So here you can fill these in. Its volume is 1/3 times base times height, or specifically for all cones, volume is 1/3 pi r squared times height. And I do want you to also add this one. It's the same as pi r squared times height divided by 3. Now, just like with our prisms, your pyramid formula is always base times height divided by 3, but our base shape is different every time. So when we're going through here, we're going to put the formulas specific to the type of pyramid that it is. So let's go ahead and do a couple of these. Here we have a square pyramid. So we're going to go ahead, and we know the volume is base times height divided by 3, but for the square it's side squared, and then it's times height divided by 3. So again, this right here was the capital B. So my volume is 9 squared times the height of this pyramid is 12. divided by 3. So 9 squared is 81. So I have 81 times 12 is 972. Divided by 3 is 324. So my volume is 324 feet cubed. Next I have a couple of cones here. Remember, your volume for your cone is pi r squared times the height divided by 3. So my volume is pi, radius is 12.4 squared. The height goes from the top of the pyramid down perpendicular to the circle through the center, so it's 20.5 divided by 3. So my volume, I'm going to keep it in terms of pi until the end. We have 12.4 squared times 20.5. And then I still have pi over 3. I'm going to go ahead and substitute pi in for 3.14 or 3.14 in for pi. And really, you could have done it in this other step too. So I have 3.14 times 3,152 and 800ths. It says let's round this to the nearest tenth, so I will take that and call that part 9,897.5 and then divide it by 3. And that gives me 3,299 and 2/10 meters cubed. Alright, here we also have a cone, so we're going to do it the same way. Pi r squared times height divided by 3. However, they're not giving us the radius, so we have to figure out the radius. And remember, the radius is diameter divided by 2. So 16 divided by 2, my radius is 8. So my volume is pi times radius squared. The height is 17 divided by 3. So I have 3.14 times 64 times 17 and then divide by 3. And I get 1,138 and 8/10 centimeters cubed. Alright, so we're going to explore some effects of changing the dimensions here. It says a cone has a radius of 3 meters and a height of 10 meters. Explain whether doubling the height would have the same effect on the volume of the cone as doubling the radius. So first we're going to figure out the actual volume of the cone. So again, pi r squared times height divided by 3. So the original volume is pi. Radius is 3, so 3 squared. The height is 10. Divide by 3. So 3.14 times 9 times 10. So 94 and 2/10 meters cubed. And now we're going to double the height. So my height is now 20. So we'll do the same thing. So we get 3.14 times 3 squared times 20 divided by 3. So I get 565 and 2/10 divided by 3. And this is 188.4 meters cubed. And so let's go ahead and compare here. If I take 188 and 4/10, divide it by 94 and 2/10, I get 2. So this does double it. So when I double the height, it doubles the volume. So doubling the height does double the volume. And now we're going to, instead of doubling the height, we're going to double the radius. So the radius becomes 6. So my volume is pi, times 6 squared, times, I'm back to my original height, divided by 3. So now it's pi times 36 times 10 divided by 3. And my volume is now 376 and 8/10 meters cubed. Well, I can see right away that it didn't double it because it didn't equal the 188 and 4/10, but we are going to check it out and see what happens. So 376 and 8/10 divided by 94 and 2/10. And this made it 4 times as large. 4 times as large. Oh, come on. And that's the volume. So when we doubled the radius, it increases the volume by 4 times. And remember, we discussed this when we were looking at the prisms. It's because the radius is squared. So if we double it, that's 2, and 2 squared is 4, so it actually makes it 4 times as large. Alright, and finally we have a funnel. A funnel has a diameter of 9 inches and is 6 inches deep. Use a calculator to find the volume of the funnel to the nearest hundredth. It says use a calculator. So they want us to actually use the pi button on the calculator. So the funnel it's shaped like a cone. So again, pi r squared times the height divided by 3. So my volume is pi, I'm just going to put in pi, times, well, I have the diameter, so I need to find the radius. And the radius is 9 divided by 2, or 4.5, squared, times the height is how deep it is, so 16 divided by 3. So volume is, when I use my pi key, on your calculator there is a pi key on all scientific calculators, and the ones that I have in my room, it's on the very bottom row of your keys, and there's an EXP button. If you look right above the EXP button, there's a little pi, but it's in orangey yellow sort of color. So you have to hit shift and then that EXP, and it'll actually show up on your screen as pi. So I'm going to hit pi times 4.5 squared, there's a little squared button, it's an x to the second power, times 16. I'll hit equals, and then I'm just going to hit divide by 3. And to the nearest hundredth, this is 339 and 29 hundredths inches cubed. Okay, that is it as far as notes are concerned. So if you want to start the assignment, it's your option. It's going to be lesson 6.3, page 278 to 280. Problems 1 to 19, 21 to 27 odd, (29 to 31). This is actually going to be due not tomorrow, so it'll be due Friday. Maybe. I might end up pushing it off. We'll see how it goes today.